If your hybrid search ignores titles and tags, your schema is the problem. We'll build Weaviate fields and hybrid queries so structured signals actually win. You see search returns that feel semantic but irrelevant. Users want exact product titles and tags to matter, not just fuzzy embeddings. By the end, you will understand how to model fields, insert items with manual vectors, and run a hybrid query so BM25 signals and vectors combine in the right order. No heavy math, just practical design decisions you can use in Python projects. I'm Professor Pi, teaching search and IR from basics to advanced, with simple, concepts-first Python that helps you solve bigger, real-world problems. Think about a product catalog search. Pure vector search is great for meaning and synonyms. Pure BM25 is great for exact phrases, tags, and IDs. Hybrid search combines them. The pain point is when the vector side drowns out your explicit fields, so titles or tags stop affecting rank. Success looks like results that honor both exact fields and semantic closeness. At a high level, the idea is simple. Give Weaviate a schema with the fields you care about. Insert objects with text that BM25 can hit and vectors that capture semantics. Then run a hybrid query that weights BM25 and vector scores. Strengths are precision on short queries and semantic recall on fuzzy queries. Weaknesses are extra complexity and tuning of the weight between the two. We will build a tiny demo, create a product schema, add 2 product items with manual vectors, run a vector-only query to show how it ranks, and then run a hybrid query that mixes BM25 and vector signals, so title and tags pull results when they matter. Now we will connect to the local Weaviate instance and confirm it is ready. This snippet connects to local Weaviate and verifies readiness. This snippet establishes a client pointing at a local Weaviate instance and performs a readiness check, so the rest of the script only runs when the server responds. It typically creates a client object with the local URL, then calls a method to check health or readiness. If the call succeeds, you get a green path to create schemas and add data. If it fails, you would see an early error and avoid calling the REST endpoints. The important parameters here are the endpoint URL and any timeout. Shortening the timeout makes the check faster but less tolerant of slow starts. Next, we will declare a product schema and push it to Weaviate. This snippet creates a product schema in Weaviate via the REST API. This snippet defines a class named product with properties you care about, such as title and tags, and registers that schema using the REST call to the schema endpoint. It specifies property types that support BM25 scoring, typically text or keyword types for title and tags, and ensures the class accepts vectors either from the server or supplied manually. The key lines define the class name, the list of properties with their names and data types, and a post request to the schema endpoint. Making title and tags searchable as textual fields is what lets BM25 pick them up later. Next, we will insert 2 product objects and include manual vector values so the vector side is controlled. This snippet inserts 2 products with manual vectors using Weaviate REST. This snippet creates 2 objects under the product class and supplies both the textual fields and a manual vector for each object. The payload for each insert includes title and tags values and a vector array, so we control the embedding without relying on an automatic vectorizer. Top to bottom, you see the object metadata first, then the vector field, then the REST call that posts the object to the object's endpoint. Using manual vectors is useful for reproducible demos and for testing how vector similarity interacts with BM25 on the exact fields. Next, we will run a vector-only search to see how ranking looks when only vectors are considered. This snippet runs a Weaviate near vector query to show vector-only ranking. This snippet issues a search that asks for objects nearest to the supplied query vector and returns results ranked by vector distance. It shows how two objects rank when the short query is interpreted purely by semantic similarity. Key parts include the near vector payload, any limit on the number of results, and the fields requested for return, such as title and tags. Observing this result helps you see what the vector model prioritizes and sets a baseline to compare the hybrid run. If the vector ranking ignores precise title matches here, you will know why BM25 needs to be added. Next, we will run a hybrid search that mixes BM25 text scoring with vector similarity, so structured fields pull weight. This snippet runs a Weaviate hybrid query mixing BM25 and vectors. This snippet composes a search that combines a BM25 style text match against the title and tags with a vector similarity score, and then fuses those signals into a single ranking. The snippet supplies the text query, the near vector, and a mixing weight that controls how much BM25 versus vector contributes. Top lines prepare the text match on title and tags. The middle attaches the vector query, and the final call asks Weaviate to blend scores. As you increase the BM25 weight, the results favor exact title and tag matches. If you increase the vector weight, the ranking moves towards semantic neighbors. Mapping this toy example to a production flow is straightforward. The same schema and hybrid call scale to larger catalogs. Swap manual vectors for an embedding service. Add more properties you want BM25 to prefer. And use an ANN index in Weaviate for performance. Recap what it is: a Weaviate hybrid search that combines BM25 on schema fields and vector similarity. When to use it: when you need exact field precision and semantic recall together. One caveat: you must tune the BM25 versus vector weight, or one side will dominate. For the next step, tune the BM25 weight relative to the vector weight and measure results with a small validation set to find the sweet spot for your queries. If short, practical IR helps, subscribe and watch the IR videos.